Let's try and see if we can solve this question here on WASSCE 2024 for private candidates, elective mathematics or further mathematics. If you want us to solve all the other questions, please kindly subscribe to this channel and share this video now. Thank you so much. Thank you. So the position vectors of 2 points P and Q relative to the origin are P equal negative 7, 4i plus j and Q equal 3i plus 7j respectively. We have to find the magnitude of 7p minus 3q. We have to find the scalars alpha and beta such that 9i plus 10j is equal to alpha p plus beta q. We have to find, correct to the nearest degree, angle between p and q. So let's begin. So the given vectors, position vectors, we have to find 7p minus 3q. So 7 times of p is negative 4i plus j minus 3q. Q is 3i plus 7j. So let's expand. We get negative 28i plus 7j minus 9i minus 21j. And this simplifies to negative 37i minus 14j. We are actually looking for the magnitude. So we put the magnitude on the result. So let's proceed further. And that will give us, so we have magnitude of 7p minus 3q, giving us 37 squared, negative 37 squared plus negative 14 squared. Square root of negative 37 squared plus negative 14 squared. And this will give us 1565. Or in decimal form, we are obtaining 39.56 units. We are looking for scalars such that 9i plus 10j equal alpha p plus beta q. So 9i plus 10j is equal to alpha p. You substitute the position vectors plus beta q, 3i plus 7j. What do we do next? Let's expand. So we have 9i plus 10j equal negative 4 alpha I plus alpha j. Then we have plus 3 beta I plus 7 beta j. So we have 9i plus 10j is equal to, grouping the items, we have negative 4 alpha plus 3 beta, negative 4 alpha plus 3 beta. Then again, grouping the j terms, we have alpha plus 7 beta j. So comparing the corresponding terms, we have 9 equal 3 beta minus 4 alpha. We can call this our first equation. Then we also have 10 equal 7 beta plus alpha. So we have two equations that we need to solve simultaneously. I know you remember simultaneous equation, how to solve them. You can use elimination, you can use substitution. So which one do you want us to use? Let's make alpha the subject in the second equation. That will give us alpha is equal to 10 minus 7 beta. So we can put this into the first equation, and that will give us we have negative 4 into bracket 10 minus 7 beta plus 3 beta is equal to 9. We have negative 40 plus 28 beta when we expand plus 3 beta is equal to 9. So this simplifies to 31 beta is equal to 49. So beta will be equal to 49 over 31. I want you to work for alpha. Have you done that? So you notice that from here we have alpha equal 10 minus 7 beta. So alpha is equal to 10 minus 7 times 49 over 31. And this will be equal to negative 33 over 31. So the values of alpha and beta are negative 33 over 31 and 49 over 31. These are the scalars, the value of the scalars. We have to find correct to the nearest degree angle between P and Q. So use the dot product. Using the dot product, angle between P and Q, angle POQ will be equal to the cos inverse of P dot Q over magnitude of P times magnitude of Q. So let's simplify this. This will be equal to cos inverse of P dot Q. We have negative 4 I plus J dot 3I plus 7J all over magnitude of Q. We have negative 4 squared plus 1 squared times square root of 3 squared plus 7 squared. And this will simplify to angle POQ is equal to, when we dot the two vectors, we get negative 4 times 3, which is negative 12 plus 7. So we get negative 4 times 3 plus 1 times 7. all over square root of 17 times square root of 58. And that will simplify to negative 5 over square root of 17 times 58. So it's cos inverse of whatever is there, cos inverse of this, cos inverse of that, and that will be equal to 99.162 to the nearest degree. That will be approximately 99 degrees. So that is the value of the angle between P and Q. Position vectors is 99 degrees.